minus 40 degrees Celsius. Wind screaming across the ice at 140 kilometers per hour. Darkness so complete, it swallows the horizon, until the sky and the ground become the same color, and distance stops meaning anything. Somewhere inside that black, howling void, a single male emperor penguin stands at the edge of a huddle. An egg rests on his feet, hidden beneath a warm fold of skin and feathers called a brood pouch. He has not eaten in months, and he cannot leave. His entire body has been reduced to one job: keep a fragile life warm in a place designed to steal heat faster than living tissue can replace it. And yet, the egg shifts. Not a sound you can hear, just a faint movement he can feel through his feet. The smallest tremor of a life trying to break into a world that does not want it. This should not be possible. No warm-blooded animal should survive here, let alone breed here, let alone raise a chick on moving ice, in hurricane winds, in total winter night. A mistake that would be inconvenient anywhere else becomes lethal here. But the emperor penguin did not read the rules. It wrote its own. Antarctica is not simply cold. It is hostile design. It is a continent that functions like a machine for removing heat from living tissue. In the interior, snowfall is so low, it qualifies as desert. What does fall often never melts. It stacks, compresses, and becomes ice so deep, it stops being weather and becomes geology, a sheet thick enough in places to shape winds and ocean currents. Temperature is only one weapon. Wind is another. Dense, heavy air pools over the elevated plateau and spills downhill toward the coast. Katabatic winds. Gravity-driven storms that can roar for days, stripping heat from anything exposed and turning movement into risk and stillness into strategy. When the wind hits your face, it does not merely feel cold. It pulls warmth out of you faster than your body can replace it. Then there is the ice itself. It is never truly stable. It grinds and buckles, fractures and reforms. Sea ice locked to the coast can support a colony 1 year and vanish the next. Pack ice drifts with currents. Icebergs calve from glaciers and float north until warmer water eats them away. The ground here is not a foundation, it is a moving platform. And still, life returns to it every year. As autumn arrives and the sea begins to freeze, emperor penguins emerge from the ocean and begin walking inland. Not toward shelter, but away from it. Thousands of birds move in long lines across newly formed ice, marching into darkness on purpose. The logic is brutal, but exact. They need a platform that stays frozen long enough to hatch a chick and raise it to the point where it can survive the ocean. If they wait for summer, the ice can break too early, and the chick would face open water before it has waterproof feathers. So emperors travel early, while the world is still tightening into winter. Some colonies are dozens of kilometers from open water. Some are farther. The walk can take days. And by the time they reach the breeding grounds, some birds have traveled the equivalent of a marathon without a single meal. Then they stop eating altogether. There are no nests here, no burrows, no warm caves, no rock walls. Just open ice, wind, and a colony that shifts with storms like a city built on a moving floor. Pairs reunite in a crowd of near-identical bodies, and they find one another by sound. In a place without landmarks, sound becomes identity. Voices rise across the ice, low and braying, each call carrying a pattern distinct enough for a mate to recognize among thousands. Then the female lays a single egg. One chance, one life, and the most dangerous moment comes immediately: the transfer. The egg cannot touch the ice. Heat loss here is so fast that contact can be fatal. So the female balances it on her feet. The male steps close, and they perform a movement so precise it looks rehearsed, guided by instinct and practice rather than sight. Egg to feet, feet to brood pouch to warmth. When it succeeds, the egg disappears beneath feathers like a secret. The female turns back toward the sea to feed, and the male stays behind, alone with winter. He will stand through darkness. He will fast through storms. He will hold one fragile life above lethal ice, waiting for the moment it either breaks open or goes silent. For the next weeks, the male cannot hunt. He cannot leave. If he abandons the egg, it dies. If he drops it, it dies. If the egg cools too long, the embryo fails. So he stands, conserving heat, conserving motion, conserving the last resources in his body. This is where emperor penguins stop being just tough and start looking like engineering. Their insulation is built from layers, dense, overlapping feathers that trap air, and a thick layer of fat beneath. Their bodies reduce exposed surface area by holding flippers tight to their sides. Blood vessels in their legs run close together in a countercurrent heat exchange, cooling blood before it reaches the feet and reclaiming heat as it returns. Even their breathing can conserve warmth, recovering heat and moisture in the nasal passages before it disappears into the air. These are not abstract adaptations. They are measurable. They are the reason an emperor can maintain a stable internal temperature while standing in conditions that would disable a human in minutes. But insulation alone is not enough. A solitary emperor penguin in these conditions would burn through energy at a rate that makes the math impossible. So the males do something extraordinary. They huddle. When the wind intensifies and the cold deepens, they close ranks until bodies press together so tightly the colony becomes a single mass. Then that mass begins to move, slowly and steadily. Penguins on the exposed edge drift inward over time. Penguins in the warm center drift outward. The structure rotates in waves, trading the worst positions and sharing the best ones. There is no leader. There is no fight for dominance. Aggression is a luxury Antarctica does not allow. Inside the huddle, trapped air warms. Heat rises. The difference between the center and the edge can be the difference between surviving and collapsing. A few inches can separate shelter from lethal wind. Our male stands near the edge. The wind presses into his back. The egg remains hidden beneath his brood pouch, balanced on his feet, the only place it can stay alive. As the weeks pass, his body shrinks. Fat burns away. Muscle begins to break down. He becomes lighter, tighter, more efficient, because the margin gets thinner every day. He does not know where his mate is. He does not know if she found open water. He does not know if storms delayed her. He does not know if she will return in time. But he knows her voice. In a colony with no nests and no landmarks, voice is the anchor. Emperor penguins can recognize individuals by their calls, and pairs can reunite in crowds that look identical to the human eye. Researchers studying penguin vocal recognition have shown that this is not guesswork. It is a real biological identification system, tuned for a world where vision and landmarks are unreliable. Then, through the storm, something threads the noise. A call. Distant at first, fragmented by wind, but patterned. Familiar. He answers. He cannot move. He cannot step out of position without risking exposure and cooling. So he calls back and trusts that sound will close a distance his body cannot. The call comes again, closer now. Another answer. Another step forward from somewhere across the colony. From the far edge of the moving city, a larger shape emerges through blowing snow. The female. She has been at sea feeding hard, loading her body with fuel for what comes next. She calls every few steps. He answers from the edge. It takes time for two voices to find each other inside a crowded world of bodies and wind. But eventually, she reaches him. They touch beaks briefly, almost formal, as if confirming the season has not broken them. Then comes the second dangerous moment, the transfer again. This is where everything can fail. A single slip, and the season ends in seconds. They reposition, feet align. The brood pouch lifts. The egg rolls across a narrow gap, balanced between failure and continuity. Seconds pass. The transfer completes. The egg is secured beneath the female's brood pouch. The male stands motionless for a moment, as if his body has not accepted that the vigil is over. He should leave immediately. He should run for the ocean. But he hesitates, because for weeks he has been the only barrier between life and ice. Then hunger overrides everything. He turns north and begins walking. The distance to open water can be long, and the route is never guaranteed. Wind erases tracks. Cracks form. The ice shifts beneath him. He is running on margins that would kill most animals. But emperor penguins live on margins. That is what they are. He walks. He rests. He walks again. And finally, the white platform ends and the ocean begins. He slips into water cold enough to punish unprepared bodies instantly. For the first time in months, he eats. As the male feeds and rebuilds, the planet turns, the orbit tilts, and slowly, almost reluctantly, the light returns. It begins as a thin blue line along the horizon, then spreads into a weak glow that softens the edges of the world. The cold does not disappear, but it loosens its grip. And in Antarctica, that small change triggers something massive. Because beneath the sea ice, the ocean wakes up. Sunlight reaches water that has been dark for months. Microscopic phytoplankton bloom, multiplying so fast they can tint the ocean in swirling green patches visible from above. Tiny organisms, enormous impact. Over time, ocean phytoplankton contribute roughly half of Earth's oxygen, and they form the first step of the Southern Ocean food web. When they bloom, something else arrives. Krill. Small, shrimp-like crustaceans that gather in swarms so dense they can darken the water like moving clouds. In the Southern Ocean, krill are not just prey. They are infrastructure. A huge share of predators here depend on them directly, and many more depend on them indirectly. Fish feed on krill. Penguins feed on fish and krill. Seals and whales follow the same pulse. The entire ecosystem rises and falls on the timing of that bloom. Krill are also part of a deeper system that reaches beyond Antarctica. When krill feed near the surface and then sink, they help move carbon downward into the deep ocean, a biological pump that influences climate. It is one reason scientists pay attention to this region not only as wildlife habitat, but as a component of how Earth regulates itself. And where life concentrates, death follows. The male emperor penguin dives deeper as he regains strength. Underwater, he is no longer awkward. He is streamlined, a flying shape in a dense world, driven by flippers that behave like wings. His body manages oxygen with precision. Heart rate can slow. Blood flow can prioritize vital organs. Muscles and blood store oxygen in ways that allow dives that would be impossible for most birds. Some emperor dives are shallow, but many are deep, and recorded dives have reached extraordinary depths. They are not simply swimmers. They are specialized hunters built for cold, pressure, and repetition. But the ice edge is a trap. A leopard seal drifts there, not chasing, not rushing, simply waiting. Built for ambush, shaped by the Southern Ocean into muscle and teeth and patience. It knows this boundary. It knows that penguins must cross it. The male sees the shape too late. A blur from below, a mouth opening. He twists, explodes upward, breaks the surface, throws his body onto the ice, breath hammering. Behind him, the leopard seal circles once and sinks into dark water. This time, the lesson costs nothing. Next time, it might. Back at the colony, the egg hatches. A chick emerges small and fragile, covered in gray down that is not waterproof and not enough to face the air alone. For weeks, it cannot regulate its body temperature. It survives on borrowed warmth, held above lethal ice beneath the mother's brood pouch. She feeds it carefully, small meals at first. Building strength and function, the chick's survival is not only about warmth, but timing, because food must arrive often enough to outpace heat loss and growth demands. Soon, the cycle becomes a relay. One parent guards the chick and keeps it warm. The other hunts. They trade roles again and again through the brief Antarctic summer, crossing long distances between colony and ocean, spending energy they cannot truly afford, because the cost of stopping is higher. As chicks grow, they begin to gather into creches, groups of juveniles huddling together for warmth while both parents hunt offshore. From a distance it looks almost peaceful, but it is still a race. Wind still bites, storms still hit, ice still shifts, predators still patrol the edges, and every day the chick grows is another day the ice must hold. Emperor penguins are the extreme, but they are not alone. Along the Antarctic peninsula, Adelie penguins return to rocky ground and build nests from pebbles, stealing and bargaining for stones like currency. Their strategy depends on a reliable summer window and predictable feeding conditions offshore. Gen 2 penguins favor ice-free coastlines and show more flexibility. Where open water increases, they often move in, adjusting timing and range in ways that give them options other species do not have. Chinstrap penguins live by precision. They time breeding to match peaks in food availability, because arriving too early or too late can mean the difference between raising chicks and losing them. Farther north, on sub-Antarctic islands, king penguins run a different plan entirely. Their breeding cycle stretches longer. They raise chicks over more than a year, trading speed for stability, betting on an ocean that stays reachable across seasons. Different strategies, same dependence on the ocean's rhythm. That rhythm is written into ice and light, and it shapes who wins and who fails when conditions shift. In some places, penguins that rely on stable sea ice struggle when freeze-up comes late or break-up comes early. In other places, more flexible species can move, adjust, or expand into new ranges as coastlines change. This is not only ecology, it is evidence of how quickly the environment can rewrite the rules of survival. Now return to the emperor colony, because the most dangerous chapter for a chick is still ahead. The first journey to the sea. Hundreds of juveniles, none of whom have ever entered open water, begin walking toward the ice edge. The ocean is not a goal. It is a test. It will feed them if they learn fast enough. It will kill them if they do not. At the boundary, danger concentrates. Leopard seals patrol like living traps. They wait at the edge where birds must enter and exit, where a single mistake creates a clean angle of attack. Above, scavenging birds watch for weakness, waiting for any chick too exhausted to keep moving. Farther offshore, orcas hunt with coordinated intelligence, pushing prey into zones where escape becomes difficult. The Southern Ocean is full of life in summer, but it is not gentle. It is abundant and brutal at the same time. The chick hesitates at the boundary between ice and water. Then it goes. No training, no practice, only instinct. The first movements are awkward. Then they begin to align with what the body was built for. The first dives are shallow. The first underwater seconds reveal a new world of pressure, silence, and cold, where the rules are different and survival depends on learning speed. Many chicks do not survive their first year. The ocean is generous, but it is not forgiving. The margin between survival and death can be days, sometimes hours, sometimes the few seconds it takes a predator to close distance. But the chick does not know numbers. It knows hunger. It knows cold. It knows the sound of its colony fading behind it as water replaces ice. And that is how this species has always lived, on the edge of what Earth allows. The problem now is that the edge itself is moving. Now the story shifts from biology to physics. In recent years, satellite observations have documented catastrophic breeding failures in emperor penguin colonies when sea ice broke up too early, before chicks were ready. A chick without waterproof feathers faces an impossible choice: enter frigid water and die, or remain on disintegrating ice and disappear with it. This is not speculation. It is visible from above. Researchers monitor emperor colonies using satellite imagery because these colonies leave signatures that can be detected and because the environment is too remote and too harsh for constant ground observation. When sea ice fails, the platform disappears and the timeline collapses. Sea ice around Antarctica has also behaved in ways that have surprised scientists, including extraordinarily low extents in recent years and a record low winter maximum in 2023. The reasons are complex, tied to ocean temperatures, wind patterns, feedback loops, and variability that models still work to capture at full speed. But the consequence for emperor penguins is brutally simple. They need the platform. They need it stable. They need it long enough. If it breaks early, the season is over. And emperors get only one chick per pair per year. One failure can erase a generation. There is another mystery here too, one that makes the story feel even more unreal. Emperor penguins return to the same breeding sites year after year, crossing long distances of featureless ice, often in darkness and storms, with no obvious landmarks. How? We track their movements with satellites. We measure their dives with sensors. We film their huddles in conditions that break equipment. And still, the mechanism that guides them back can feel invisible. Some researchers explore the possibility that they sense Earth's magnetic field, a kind of biological compass. Others suggest that low-frequency sounds produced by wind and ice might create an audible landscape for animals tuned to it. There are theories about subtle gradients in light, wind patterns, texture underfoot, memory of ocean conditions. The truth is, we do not fully know the map emperor penguins carry inside their bodies. We know it works. We know it brings them back. But we do not see it. Some colonies have shown flexibility, breeding on different ice platforms when sea ice becomes unstable. That offers hope. The question is whether adaptation can move faster than the changes now unfolding. Because evolution is powerful, but it is not fast on human time. Back to our colony. The adult male returns from the ocean heavier now, restored by food and time. He calls, and somewhere inside the mass of bodies, an answer returns. The chick is larger now, still gray, still learning what cold means, still living on deadlines. The parents continue their relay through the brief summer. The chick grows. Down gives way to juvenile feathers. Legs strengthen. The instinct to move toward open water rises again. Then the colony begins to thin as young birds step toward the sea. Some will survive and spend years roaming the Southern Ocean, learning currents, learning prey, learning danger. Some will not. That has always been true. What is new is the instability of the platform that starts everything. The timing, the ice, the edge. Tonight, the wind carries snow across the ice like smoke. Adults turn their backs to the gust and tuck their young closer. Hundreds of birds perform the same motion, the same reflex, the same endurance, because cooperation here is not kindness. It is survival. This is why the Emperor Penguin story matters. It is not only a story about endurance, it is a story about a biological schedule synchronized with a physical platform, and what happens when that platform becomes unreliable. Penguins have always lived at the edge of what the planet allows, but now the edge is moving, and nobody knows how far it will move, how quickly, or whether every colony can follow. Scientists can model outcomes and compare them with observations. Satellites can measure sea ice extent and track changes in habitat. Field researchers can measure physiology, breeding success, colony stability, and population trends. The evidence grows stronger each year that timing is shifting in ways that increase risk, especially for species that depend on sea ice for breeding. For now, though, on the frozen bottom of the world, a small heartbeat continues. The wind keeps blowing, the ice keeps shifting, and in darkness that would crush a human spirit, life holds on. One breath, one call, one step at a time. It has held on for a very long time. Whether it holds on for another 100 years is no longer guaranteed. But tonight, it holds. And that is enough.